A very good evening, guys. So welcome, guys. Join fast. So in the today's session, we are going to be having questions on design of prestressed concrete of our atomic series. So welcome to our BARC and HL preparation course crash. And in the today's session, we are going to be discussing numericals on design of prestressed concrete. Join fast, quick, everyone. Welcome to the BYJU'S Exam Prep. And subscribe to the channel, click on the like button and bell icon if you like this session. Okay, so we are here with you, a very exciting crash course for your BARC and HL preparation, and we are also coming up with other very exciting sessions, right, in which you are going to be given knowledge about all the aspects regarding the preparation. This is the one-stop solution for all your needs, okay, whatever it may be. Okay, be it your strategy, okay, be it your planning, okay, be it your subject guidance, okay, specific exam guidance, okay, each and everything is going to be provided to you at one platform itself. So welcome everyone, welcome guys. So join fast, quick everyone, quick guys, quick join. We are about to start. So do comment in the chat section and let me know all those who have joined already. Comment in the chat section, everyone. So let me introduce myself. My name is Rohan Goyal and I have a master's degree in structural engineering from IIC Bangalore. I have scored an All India rank of 96 in GATE 2020, and these are the subjects that I teach at BYJU'S Exam Prep. So join fast, quick everyone. Comment me in the chat section and let me know all those who have joined already. And you will be provided with a PDF of this particular session on my Telegram channel. So you have to search Civil by Rohan Goyal. You have to search Civil by Rohan Goyal. So over here, you will be provided with the PDF of this particular session. Okay, I will provide you the PDF right after the class. Okay, and I am also providing daily dose of important concepts, questions, okay, any information related to the exam, okay, any notifications for the class that we are going to have over here, okay, your PDFs, notes, and your doubts are also going to be resolved at this channel. If there is any doubt from the session, you can ask me in this Telegram group, and your doubt is also going to be resolved. So join fast, quick everyone. We are about to start. So another notification that I would like to give you all, that we are conducting one important session for all the GATE 2023 aspirants. Okay, this session is conducted by Abhinav Negi Sir. Okay, and it is going to be conducted on 13th of March at 12:30 p.m. on BYJU'S Exam Prep app. So this is going to be conducted on app. Okay, so all those who are aiming for GATE 2023, you can join this session on 13th of March at 12:30 p.m. with Abhinav Negi Sir, and he will guide you how to conquer GATE 2023. So he is an expert in telling you what is the strategy to conquer GATE 2023 and how BYJU'S is going to help you to do so. A very good morning, okay, Shahrukh Khalam. A very good evening. Sorry, I also read good morning. A very good evening, Parmesh. Welcome. Welcome guys, welcome. A very good evening to all. Welcome guys, join fast. So next slide we are going to start with the questions, right? So I would like you all to join fast. Click on the like button and send a thumbs up button in the comment section so that I may know that you guys are ready to start solving problems on prestressed concrete. So that I know that you guys are ready to solve problems on Prestressed concrete. Click on the like button, send a thumbs up button in the comment section so that I should know that you guys are ready. Sir, 6 PM CS की class बंद हो गई. I hope you mean CS means computer science, right? Am I right? Bhumi? Am I right? So I'm not aware of that class. Okay, if you are talking about computer science. Okay, so I have to check it and let you know. So you can ask, you can comment this in my Telegram group. Okay, over there I will let you know what is the status. Okay, you can ask me on my Telegram group. You can join my Telegram group, Civil by Rohan Goyal. Over there you can ask me the same thing and I will let you know what is the status of that class. All right, so let us start. Let us start, guys. So here is the first question that you are having. So you are given a simply supported concrete beam which is pre-stressed with a force of 2500 kilonewton. Okay, so let us use some other color for marker. Okay, so 2500 kilonewton and is designed by a load balancing concept for an effective span of 10 meter. To carry a total load of 40 kilonewton per meter. The central dip of the cable profile, which is parabolic, should be, what is the central dip? So tell me what is the answer, guys. Tell me what is the answer. Yes, guys. Siman Singh, yes, of course I can speak in Hindi, but this is the English channel. So over here, the sessions are to be conducted in English only. So the medium of communication is English at this particular channel. If you want to watch sessions in Hindi, we have a Hindi channel separate. So you can join that channel for if you want, if you are more comfortable in Hindi. All right. So what is the answer? Tell me. Very good evening, Suraj. Welcome. And guys, if you all know that I have started a mini concept series. Okay, so I am providing very short concepts. Okay, and I am trying to bring those short concepts on a daily basis. Okay, if there is anything that you guys want, that sir, this kind of sessions are required in which I can help you with, okay, some short concepts, any topic that you are confused, you want me to tell you some little topic which you do not know, okay, you can comment in the chat section or also tell me on my Telegram group. Okay, I will definitely make a video on that particular topic. Okay, if there is any topic in which you are confused and you want to know a bit about that topic, you can tell me by either commenting upon in the chat section right now, or you can tell me on my Telegram group, Civil by Rohan Goyal, and I will definitely make a video upon that particular topic. So tell me what is the answer, guys? Combined stress. Okay, okay. Pramesh, definitely it is going to be taken into consideration. Yes, Suraj. All right. So let us solve this question, guys. I think the class is deviated from the question and students are not solving the question. So let us solve. So let us see what are the given data. So pre-stressing force is given and we are asked to find out what is the central dip of the parabolic profile of the cable. Yes, very good, Star. The answer is 200. Okay, it is mm, not meters. So these are all mm. Right? So these are all mm. So obviously 200 meters. How can the dip of a parabolic profile be 200 meters? That is not possible, right? So, okay. Now, the central dip should be designed such that it should balance the total load that is acting upon the section. So the total load, so when we have a parabolic profile, what is the balancing UDL from below? The balancing UDL, the formula for the balancing UDL is 8ph upon L square, where this h is your total dip. Okay, so the central dip will be equal to h. So now in order to balance this 40 kilonewton meter, your balancing UDL that will come due to the parabolic profile should be equal to 40. So that means this WB should be equal to 40 kilonewton per meter. So 40 should be equal to 8. Pre-stressing force is given to you as 2500 kilonewton. Into h we have to calculate, divided by length is given to you as 10 meters, so 10 whole square. So if you simplify this, your h will come out to be equal to, so 40 into 100 divided by 2500 multiplied by 8. So this cancels out. This is 2, 5, this is 5. So this will come out to be equal to 0.2 meters, which is equal to 200 mm. Any doubt? So the answer to this given question is B. B is the right answer. Any doubt to anyone? You will get the PDF on my Telegram channel, Civil by Rohan Goyal. You have to search Civil by Rohan Goyal. You have to search Civil by Rohan Goyal. At this Telegram channel, I will be providing you the PDF of this session. Next question. So, next question, guys. So, you are given a simply supported prestressed concrete beam of 6 meter long. So, the length of the beam is given to you as 6 meter with 300 meter wide and depth of 600 mm. This is going to be mm. Another little mistake. So, this is also mm, 300 mm wide. Okay. The prestressed by a horizontal cable. So we are providing a horizontal cable which is at a uniform eccentricity of 100 mm. The prestressing tension force in the cable tandem is 1000 kilonewton. Neglect the self weight of the beam. The maximum normal stress in the beam at transfer is. So what is the maximum normal stress? So let me draw the diagram, okay, and you can start solving. If you know how to solve the question, you can start solving simultaneously and you can tell me what is the answer to this given question, right? You can tell me what is the answer. All right. So this is your pre-stressing cable. So the pre-stressing force is over here. It is simply supported. It is simply supported, and this eccentricity is how much? 100 mm. Pre-stressing force is how much? 1000 kilonewton. So if you cut a section over here, let us cut any section. So this is my section. Okay. This is my section. And the pre-stressing cable is somewhere over here. Pre-stressing cable is somewhere over here. Pre-stressing force is acting over here at an eccentricity E. Now due to this pre-stressing force, what are going to be the stresses? So this can be converted into two parts. It can be converted as a direct load P and a bending moment M whose magnitude is P times E. I hope it is visible. I hope it is visible. Okay, M is equal to P times E. Okay. So what are going to be the stresses? One is going to be uniform compression due to the direct load P. Due to the direct load P, uniform compression whose magnitude is P by A. And another will be bending stresses, which will be tension on the top and compression on the bottom. Okay, clear? Is it clear? Yes, very good. I guess Abdul has given me the right answer. Right. So if you know the direct formula, you can use the direct formula also, right? Okay. So what will be the maximum compressive stress, maximum normal stress? So sigma max will be equal to P by A plus P by A plus PE upon I into Y max. So you have to substitute all the values. P is how much? 1000. So 1000 converted into Newton divided by area. Area is 300 into 600 plus P plus PE, eccentricity is 100 upon I, or you can say I upon Y max is equal to what? Section modulus, which is equal to BD square by 6, right? So Z is equal to I upon Y max, which is equal to BD square by 6. So you can directly substitute this value also. So B into D square by 6. So if you solve this, tell me what is the value you are getting. Tell me what is the value you are getting, guys. Yes, so you will get 11.11 megapascal as the answer. So the answer will be C, right? Any doubt to anyone, guys? Is it clear to all? Quickly comment thumbs up button in the comment section and let me know if it is clear to everyone. Quickly comment thumbs up button in the comment section and let me know if it is clear to everyone. Is it clear to all? Is the concept clear to all? Very easy question, straightforward question. Yes, everyone. Yes, everyone. Is it clear to everyone? Very good. Very good, guys. Next question. So again, this question is on the losses of the pre-stress. Okay, now we are going to see some questions on the losses of the pre-stress. All right. So concrete beam, not beama. It is not beama. A concrete beam of 10 meter span, 100 meter wide, 100 mm wide and 300 mm deep. This is mm. Okay. 10 meter span, 100 mm wide and okay, is pre-stressed with the pre-stressing cable of cross-sectional area of 200 square mm square. Initial pre-stress of the cable is 200 megapascal. The cable is parabolic with an eccentricity of 50 mm above the centroid and at the supports and 50 mm below the centroid at the center of the span. Estimate the percentage of loss in the stress in each cable due to friction, assuming mu as 0.35 and wobble correction factor as 0.0015 per meter. Determine the percentage loss of the stress due to the friction when the cable is tensioned from one end, that is, it is jacking from one end. It is a case of jacking from one end. Let us understand the problem first of all. Quickly, let us understand. So this is the cable which is given to you. This eccentricity at the end is 50 mm. Let us call this as E1. And this at the mid is E2. So E1 is equal to E2 is equal to 50 mm. It is given to you. Further, all the things are given to you. So first of all, what is the formula of the loss in the pre-stress? P naught Kx plus mu alpha. So K value is given. X is what is the length of the initial pre-stress point to the maximum loss point. So for example, if the jacking is done from only one end, suppose let us say the jacking is done from this particular end. So this particular end is pulled outwards. In order to tension the wire, this particular end is pulled outward. This particular end is only this end is anchored. This end is anchored and the other end is pulled outward. When the other end is pulled outward, the loss will be occurring throughout the length of the wire. The loss will be occurring throughout the length of the wire. So in this, the Kx will be equal to 10 meter. Mu, you know, alpha is the change in curvature. So what is the total change in curvature between the 2 points considered? So this value is alpha, which is equal to 8 P 8 H by L, sorry, for 8 H by L. This is equal to 8 H by L. 8 H by L. So this is equal to 8 H by L. Okay, so you have to substitute 8 H by L. That is 8. H is how much? E1 plus E2. E1 plus E2. H is equal to E1 plus E2. That is 50 plus 50. Divided by L. Length is how much? 10 meters. So 10 meters converted into mm. So this will be your alpha value. Substituting the values, the loss in the pre-stress. So what is the percentage loss? So let us ease our calculations. What is the percentage loss is equal to PL by P naught into 100 into 100. Right, so PL is P naught this, so it will be P naught Kx plus mu alpha divided by P naught into 100. So P naught and P naught cancels out, so percentage loss will be equal to Kx plus mu alpha into 100. Okay, so percentage loss is Kx plus mu alpha into 100. So percentage loss is into 100. So which is equal to K is equal to 0.0015, X is 10 meters plus mu is 0.35, alpha is 8, 50 plus 50 divided by into 100. Calculate and tell me what is the answer. Calculate and quickly calculate and tell me what is the answer, guys. So I want quick calculations from you all. I will see whether you are attentive or not. I will get to know if you are able to, if you are telling me what is the answer, I will get to know whether you are attentive or not. Okay. So the answer you will get is 4.3%, right? So very good, Abdul, very good. So the answer to this given question is C. C is the right answer. C is the right answer. No, how come you are getting 1.78, Suraj? No, your answer is wrong. What about others? What about others? Why am I not getting any answers from other students? What happened? What happened? Why am I not getting any answers from the other students? Alright, moving on. Next question. So, you are again given a... Okay, so a post-tension prestressed concrete beam is given 100 mm wide, 300 mm deep, okay, and you are provided with three cables which are each having an area of 50 mm square. So, three cables each having an area of 50 mm square with an initial pre-stress of 1200 megapascal. All the three cables are straight and located at 100 mm from the soffit of the beam. Okay, that means from the base of the beam. If the modular ratio is 6, the loss in the pre-stress due to the elastic shortening of beam. So due to the elastic shortening, what is the loss? So you know what is the loss? Modular ratio times stress in concrete at the location of pre-stressing cable. So the wires are simultaneously tensioned. That means all the wires are tensioned at the same time. All the wires are tensioned at the same time. Now understand. Okay. If you know, tell me the answer in 1 minute. If you know what is the answer to this question, tell me the answer in 1 minute, first of all. I want you to answer the same question in 1 minute. If you know, tell me the answer in 1 minute. Quick. 0. Very good, Abdul. Excellent. Excellent. That is what I was expecting. Those who know the answer, they will tell the answer in 1 minute. The answer is 0. Why? Why 0? Why 0? Because in the case of simultaneous tensioning, this is concrete. Let us say this is my concrete. Okay, and these are my cables which are provided at an eccentricity. Okay. Now when I tension this wire, when I provide the force, now suppose if I want to pull this pen out of my fist, what would I have to do? I would have to hold my fist at one location. If I have to pull the pen out of my fist, I have to hold the fist at one location. If in case I am not holding the fist at one location, then what will happen? My fist will move along with the pen, it will not come outwards. So if I want to pull the pen out of my fist, I have to apply an equal and opposite force towards or by my hand. Okay, so similarly, when I want to pull the wire out of concrete, when I want to stretch the wire out of concrete, I have to hold the concrete at one location. So I have to apply an equal and opposite force over the concrete. Yes or no? I have to apply equal and opposite force over the concrete. And when I am applying an equal and opposite force, what is happening? The concrete is getting compressed. A compressive force will be acting. Equal and opposite compressive force will be acting over the concrete. And due to this compressive force, the concrete will undergo elastic shortening. Due to this, the concrete will undergo elastic shortening. Yes or no? The concrete will undergo elastic shortening. And this is during the tensioning process only. The anchoring of the wire will be done at this location. The anchoring of the wire will be done at this location. So there will be no loss in the pre-stress due to this when the wires are simultaneously tensioned. So there is no loss in the pre-stress. The loss in the pre-stress is 0. But if the wires are tensioned successively, this is a question which has been asked in GATE 2022 also. Similar question has been asked in GATE 2022. Yes or no? Yes or no? Similar question has been asked in GATE 2022. This same question has been asked in GATE 2022, and I have done this question many times in my classes. Same question has been asked in GATE 2022, guys. So, what has it asked? It has given the same type of question and it has given successive tensioning. Now, first you will tension first wire, then you will anchor that. Let us do it. Okay. So, this is my wire number 1. So, when I tension this, elastic shortening occurred, delta L. Okay. So, I will anchor it over here. I will anchor it over here. Okay. Now, then I will tension the second wire. Second wire. Now due to this, further some elastic shortening will occur, delta L, and I will anchor over here. Now if you notice one thing, in the wire number 1, this is loss in the wire number 1. This delta L is a loss for the wire number 1, because this much of strain has been lost in the wire number 1. Now further I will tension wire number 3. Wire number 3. Okay, I will tension wire number 3. Due to this, further elastic shortening will occur, and I will anchor it over here. Now if you see, due to the tensioning of wire number 3, further delta L is observed in wire number 1 and 2. This loss is observed in 1 and 2 both. In wire number 2, delta L is there, and in wire number 1, delta L plus delta L is there. Are you able to understand the concept? Are you able to understand how the loss in the deformation is taking place in wire number 1 and wire number 2? So this is what you have to calculate. What is the loss in the pre-stress in the wire number 1 and wire number 2, right? So you have to first of all find out what is the deformation that is taking place, delta L. Okay, so you are given what is the force that you will be applying. Force will be equal to stress into area. Stress is 1200 megapascal into area is 50. So this is the force. So the deformation will be, this is at 100 mm, right? Okay, modular ratio is given. So loss in the pre-stress PL in wire number, so loss in the pre-stress will be equal to M times FC. FC is the stress in concrete at the location of pre-stressing wire. So what is the stress in concrete at the location of the pre-stressing wire? This you have to find out. So this is a little lengthy question, okay? This is a little lengthy question, okay? So if you find out, you will have to first of all find out stress at this location. You have to first of all find out stress at this location. This is eccentricity E, okay? So FC will be equal to P by A. This is not visible, right? FC will be equal to P by A plus P E upon I into E. So this will be your FC value, right? So FC will be equal to P is how much? 1200 into 50 divided by area is how much? 100 mm into 300. 100 into 300 plus P 1200 into 50 into E square, eccentricity E. What is eccentricity? 100 mm from the soffit. So if this is 100, so this will be, this E will be 300 minus divided by 150 minus 100, so E will be equal to 50. So 50 whole square divided by BD cube by 12. So if you simplify this, what is the value you are getting? What is the value you are getting over here? From here, what is the stress in concrete at the location of pre-stressing wire? So this is the same thing that you are doing in the first question, right? You are finding out the stress in concrete at the location of pre-stressing wire, right? So what is the value you are getting? I hope you are getting 8 megapascal over here. 8 megapascal. So what is the loss in pre-stress? Will be equal to M times FC, which is equal to 6 times 8. That is 48 megapascal. 48 megapascal. All right. Now, in wire number 1, PL in wire number 1 will be equal to, due to delta L plus delta L, due to 2 times delta L, right? So it will be 2 times 48, which is equal to 96 megapascal. In wire number 2, it will be only due to one delta L, so 28 megapascal, 48 megapascal. And in wire number 3, there will be no loss, 0. So the average loss will be, 96 plus 48 plus 0 divided by 3, which is equal to 48. So the answer will be A. Similar question has been asked in GATE 2022, guys. Similar question has been asked in GATE 2022, and we have done this question many times. You will not be asked this high level of question in BARC examination, but a concept may be asked from this particular question. That is why I have taken this question. Next question. The percentage loss of pre-stress due to the anchorage slip. So this is a very easy question. I hope that you can solve this question. Okay. So what is the percentage loss? What is the percentage loss due to anchorage slip of 3 mm? 3 mm anchorage slip is given for beam of length of 30 meters, and a force of 150 kilonewton is there at an eccentricity of, one second, sorry, the question has changed. Okay, 30 meter, okay, and pre-stress of 1200 megapascal is given, and modulus of velocity is equal to 2.1 into 10 to the power of 5 megapascal. This is 10 to the power of 5. So what is the anchorage slip? So what is the loss due to the anchorage slip? Percentage loss due to the anchorage slip. So what is the loss in the pre-stress? It is equal to delta L by L into Young's modulus of velocity of steel. This is the loss in the pre-stress, right? Strain into Young's modulus of velocity. This is the loss in the pre-stress. Delta L is 3 mm. Length is 30 meters, so 30 into 10 to the power of 3 into 2.1 into 10 to the power of 5. So this is how much? 4. So 21 megapascal. So this is the loss in the pre-stress. So percentage loss will be equal to PL by P naught into 100, which is equal to 21 divided by 1200 into 100. So this cancels out. So this comes out to be equal to 21 by 12, which is equal to 1.75%, right? You will get 1.75. Clear? So the answer to this given question is C. C is the right answer. Okay. Clear everyone? Any doubts? And now I am going to give you some homework problems. Okay. So these problems, if you are able to solve, okay, you tell me in my Telegram group. Okay. This is first homework problem. Okay. And this is the second homework problem. No, only one homework problem is there. This is a homework problem you have to solve, and you have to tell me, you have to give me the solution on civil by Rohan Goyal group. The solution to this question is going to be provided on my group over here. The solution to this question will be provided to you on my group over here. This is a homework problem. You have to first send me the solution yourself. Okay. Then I will provide you the solution. Okay. You will send me your solution first. Okay. Very easy question. Okay. You are asked to find out the percentage lost due to the elastic deformation of concrete. Okay. So this is another very easy question. Okay. Similar type of question. So you solve this question and tell me what is the answer on my Telegram group. Okay. And I will provide the solution tomorrow. Okay everyone. So with this we wind up our today's session. Thank you. And if you like the session, click on the like button. Click on the bell icon so that you can get all the notifications of the upcoming sessions. And do subscribe to the channel, guys. Do subscribe to the channel, to the BYJU'S Exam Prep channel. Okay. And thank you everyone. Goodbye and take care. That's all for the session everyone.